next question is asking us to use the definition that an integral is in fact an infinite summation. If I have y equals 1 over x, then I want to add up little rectangles between x equals 2.1 and 6.3. Then this is what we would get. We would find all of this. Of course, there's some gaps, but that would be the sum. If I say that the width of a rectangle, they're all going to be the same as delta x, then you can see I'd have my function 2 over x for a specific value of x, like 2.1 for example, and I'm going to times it by the width, and I'm going to do that for all my values. So I'm going to go from 2.1 to 6.3, and that'll give me the sum of these rectangles. Now, if I reduce the width of delta x, then I'm going to get a better and better estimate. So we let delta x approach 0. And that is what we then define to be an integral from 2.1 to 6.3. And it's actually another bit of maths that then shows that that is the antiderivative, the opposite of differentiating. But I'm just trying to explain roughly where this comes from. So in our case, we've got this formula. We can see that f of x is 2 over x. So it's going to be the integral of 2 over x with respect to x, little dx. And then I'm going to be integrating from 2.1 to 6.3. That is my answer. Hence show that we get ln k for some k. Well, let's do the integral then. So 1 over x integrates to ln x. 2 over x, I'm just timesing by 2. Just bring it out as a little factor. It's going to be 2 ln x. Actually, there's a modulus sign around it as well. We'll get away with that here, but you should always put it in, really. Now we're evaluating between 2.1 and 6.3. So 2 ln 6.3 minus 2 ln 2.1. I could bring the 2's up. I'm not going to yet. I'm going to factorize it out. And now I can use rule of logs and combine them. Gives me 2 ln 6.3 over 2.1, which is actually 2 ln 3. It's not quite how we're asked to leave it, because we're asked to leave it just as ln k. The final answer is going to be ln 9. We could say that k is equal to 9, but it's absolutely fine to just leave it like that. Well done.